Welcome. In this lesson, we're going to learn how to use the product rule to find the derivative of a relationship or a function that's actually made up of two smaller functions multiplied together. So I have written up the top here where y is equal to u times v. And that's the form you have to get your function into in order to apply this rule down here. So there's the function and there's the derivative. And the one thing that might be confusing thus far in the lesson is that there's no x in here, but I am finding the derivative in terms of x. And that's because u is equal to a function of x, like 2x, sine x, e of x, and v is equal to many of the same things. So learning how to apply this rule is best with an example. I thought we could use the function y is equal to x squared times sine x. Now, as I said before, the first thing we've got to do is get into this form, y equals u times v. And I said u and v are both functions of x. So the first function of x is x squared, and the second function of x is sine of x. So just below it we say, well, u is equal to x squared, and v is equal to sine of x. And then just below those two you derive it in terms of x. So du dx is equal to 2x, and dv dx is equal to cos of x, using our derivative laws. I should mention that the end goal here is to find what dy dx is equal to, but so far we only have du dx and dv dx. So using this bit of information here, we can actually complete the formula that we have up here. So yes, hope everyone realizes that this is a y up here. dy dx is equal to, now looking at the formula above, it's v, and v is sine of x. We plug that in. Sine of x times, and it's du dx, so we plug that in down there, times 2x, plus u, which is x squared, times dv dx, which is cos of x. Now sometimes you'll see this formula written the opposite way, so it's u dv dx plus v du dx, but I like to write it the first way because that way you only have to change it slightly to switch to the quotient rule, which you'll learn later. And further on that, the easy way to remember this formula is just put the opposite letters next to each other. So here it's v and du, and over here it's u and dv. And it's not a very difficult one to remember. So going back down, I can easily put this into a better form. 2x sine of x plus x squared cos of x, and then I've found the derivative of y equals x squared sine x. Let's do another example to the right. This one pops up all the time. So if you can almost memorize the steps, I can guarantee you'll get some marks somewhere. It's y is equal to x log e x. So the first thing we've got to get it into is this form here, and it's easy to see that this is going to be u and this term is going to be v. So we say u is equal to x and v is equal to log ex. Du dx is equal to 1. dv dx, well, the derivative of log ex is 1 on x. And then we're all equipped to find dy dx. dy dx. And that's equal to the formula v du dx plus u dv dx. It's the same one we have up there. And now we substitute in, well, what's v? V is log ex, so it's log e x times du dx, that's 1, plus u, which is x, times dv dx, which is 1 on x. So we come out with log e x plus x on x, that's log e x plus 1. Now there's one last thing that I want to talk about when it comes to the product rule, and that's the tricky things that examiners tend to do. When instead of writing u and v, they might say something like u is equal to g of x and v is equal to h of x. Now here we know that u is equal to, over here, x squared. So we know that u is a function of x. But up here they're just reasserting that u is a function of x by actually writing it as a function. In fact, they could even write u of x, but I'm just going to write it as g because it's a lot more common. So then what you have is, we'll say y is equal to f of x. Instead of y is equal to u times v, we get f of x is equal to g of x times h of x. And the same formula applies if we want to find the derivative of f of x. Then that's equal to u, which here is gx times the derivative of h of x. So normally we'd say, we'll start with v. Sorry, I've got that in the wrong order. We'll start with v. So we've got h of x times, normally we have du dx, but here du dx is just going to be g dash x, and then that's plus on the other side g of x, which is equal to u, times dv dx, which in this case is equal to h dash x. Sorry, going off the side of the screen there. So in multiple choice, this tends to be what pops up. And the very handy thing that comes from the product rule once we get into integration is this fact. See how we've started with a function of y up here, we've found the derivative. We can also go in the opposite direction. If you haven't done integration, just ignore this. But we can say the integral of dy dx in terms of dx is equal to y. Therefore, we rewrite it. The integral of dy dx is equal to, as we found, log e x plus 1. That's dx is equal to, well, y was equal to x log ex, and we can split this integral up, the integral of log e x dx plus the integral of 1 dx is equal to x log e x. Now I've run out of space, so we'll go over here. Therefore the integral of log e x dx is equal to, we'll say plus, and we're going to solve this integral down here. That's x is equal to x log e x. So finally, the great bit of information we have from here is that the integral of log e x is equal to x log e x take x. And this is not an integral you have to remember, but a lot of people in my class found actually remembering it was very handy. But see how we've ended up deriving it from the product rule.